Thank you very much. Appreciate being back here at RSA. My name is Toby Zimmer. I'm a senior director with Optiv. I specialize in protecting what's important. Cryptography is definitely one of those things that's one of the drivers behind it. I've been working in this space over 25 years. I want to have a conversation with you today about hurting certs. How you automate certificate lifecycle management. What are some of the things behind it? What are some of the drivers behind it? This is a really practical session. There's going to be some things I talk about in order to set some context around what are some of the drivers that are happening in the industry. More importantly, we're going to dig into some of the things around the policies and procedures. We're going to actually go into a certificate lifecycle management solution set at a high level and start to talk about how does it work? How do you automate? How do you start finding where your certs are? And throughout this whole this session, by all means, ask questions. There's a lot of content in this deck. Not all of it's in the front side of this presentation. There's a lot of stuff in the appendix. Please download it. There's a lot of details in there around particularly policies and procedures, some of the sample language around it. This is here to help you actually be ready to actually start taking action. So of course, a fantastic disclaimer. These are my opinions, my thoughts, my experiences. Do not rebroadcast, retransmit, or reproduce without express written of the National Hockey League. Have fun. So what's the agenda? What are we going to talk about? First, let's talk about what's going on in the industry. What are some of the things that are happening right now from an operational perspective? What are some of the regulatory challenges that are coming up? What are some of the things that are happening from a future state perspective with quantum that's really driving the need for us to start automating certificates, starting to manage it? Second thing we're going to get into is actually starting to look at how do you build certificate policies and certificate procedures. Who here knows what a CP and a CPS is? Who here doesn't? So if you ever want to have a lot of fun, go out on the internet and take a look at one of the publicly available ones. They're massive. I've seen them like 200 pages. They're a lot, but it is the foundational thing you need to have in place in some aspect, not 200 pages, that defines a lot of the key aspects of how do you issue, manage, control certificates within your organization. It even goes as far as cryptographic keys, so the symmetric keys can be applied to this as well. The last part of this is going to get into certificate management. How does it work? How do you leverage certificate lifecycle management solutions out there and start discovering, managing, automating, and streamlining the way you issue, manage, revoke, and destroy certificates? Let's talk about what's going on in the industry. There's not a lot of surprises here. Some of it you may not have as much knowledge on what's going on right now. So first of all, managing certs is like managing and hurting, name it, kids, IT professionals, cats. I have cats, herding cats. We're struggling with this. Why? There's a lot of reasons why this is happening. The number of things that are out there right now that can allow us to generate a certificate is growing exponentially. We can look at things around the use cases around it. We're using certs for a lot. Pretty much everything nowadays on it has a certificate in some way, shape, or form. So we are using certificates a lot more as part of our day-to-day operations, and it's super easy to acquire. I can go out to any one of the major certificate repositories, you name it, Entrust, DigiCert, GoDaddy, whatever, and I can buy a cert like that. 5 minutes. Registered, good to go, start using it. And this is one of my favorite ones. If I've got a cert, I'm secure. Piece of cake, good, check the box, kick my feet back, and I'm all set, right? Wrong. Perception is not reality here. Certificates are part of security, but there's a lot behind this that we have to start to address. And this is another one of my favorite ones. I'm working with a client right now, and this is always a fun topic because I start to stand something up in a test, and I'm using a certificate I've issued, more than likely self-signed internally, and the next thing I know, it's like, hey, let's just make it easy. Let's just throw it up in the cloud, and I'm running it in production. Cool. I just had some developer put a cert up in production, and I've got no idea what it is, how it's set up, how it's managed, who issued it, yada, yada, yada. It's a challenge. But our dev life cycle, our rush to market, is starting to mean that we have a lot more certificates out there right now that we don't know what they are, how they're issued, who owns them, and they're on our forward-facing systems. This is always one of my favorite ones, because guess what happens once I push this out and I'm a developer? Next thing I'm on is my next development project. Whoops, forgot the certs out there. And then it expires. and then you have an outage. And who gets blamed when you have an outage? Cyber, CERT team, yep. Now they're calling you like, why is this down? Well, if you don't know who issued it, where it is, now you've got a problem. And this is probably one of my favorite ones, right? We start losing ownership of these certs. People leave, people stand these things up and get new jobs. They walk away. This happens. We're in that industry where things happen. I'm dealing with something right now with 2 clients. Part of their public key infrastructure is using hardware security modules. Well, the people who had the hardware security modules left. The people who had those modules who left had the passwords. Guess how many backup passwords they had? 0. Who in here knows what happens when you enter a password too many times in a hardware security module? It wipes itself out. All my keys are gone. So I've got a problem right now that these people leave. I don't have control over the keys. And in these 2 cases, I'm rebuilding their entire PKI, ground up. Now I've got to reissue all those certs, help them put all these policies and procedures in place, et cetera. The net here is that there's changes here that are happening. These things are going to impact how we operate and run businesses. And this is also, we're going to start seeing industry trends and regulatory needs that are going to start pushing the need to manage this. So, how's this changing? Machine identities. You've probably heard this part through the way of the conference. If those of you have not, we're going to talk about some of the stats here. It's estimated that machine identities outnumber user identities 45 to 1. So 8 billion people on the planet, 350 billion machine identities. And every user has approximately, they're saying on average, digital identities. Hey, there's that RF cutout again. It's all good. There is 30 identities on average per user. If you think about it, what identities do you have right now? What digital identities do you have? Mobile phone, laptop, authentication, email signing, email encryption, drive encryption, blah, 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 right? So if I've got 10 digital identities for myself, and there's 8 billion of us on the planet, that means I've got 80 billion certificates. That now means I've got 3.25 trillion, or 3.5 trillion digital identities I have to manage for all the machine identities out there. It's daunting. Think we can do that on a spreadsheet? Nope. Think we can do that at scale? No. It's a challenge. So this is a big driver right now in the market that organizations are struggling with. And of course, leaders are now starting to get concerned that the time to manage this is extensive. And in some cases, there are multiple organizations and departments that are running certificates. I'm going to touch on this a little bit because there's a perception out there on who owns the management of certificates. And I'm going to share some insights on what I'm seeing in the industry. So for those of you who are trying to visualize what are machine identities, top stuff's pretty easy, right? Whoops, let me go back. Pretty easy stuff we can associate with this, laptops, mobile devices, et cetera. This gets interesting. Every server I stand up in the cloud, every Docker image, every Kubernetes image I stand up, those are all machine identities. And how fast can I stand up a machine identity? Cloud instance, I can have this up and running in an hour, and I can have hundreds of these things out there, like that. This is probably one of the main drivers right now of why we're seeing so much growth in machine identities, because we are spinning up virtual systems very quickly. We're standing up virtual platforms very quickly. Artificial intelligence is going to put another spin on this, because we all just think AI is this thing. AI is a machine. There's going to be a digital identity associated with it. And the more AI we get, the more digital identities we get. So these are just some examples to take away and think about as we start talking about the challenge of managing a certificate and managing this across a complex organization. Google. Google is proposing a change to require TLS certificates to be rotated every 90 days. This has been in the works for a little while, it's over a year now. You know, and their purposes behind it's pretty compelling. For forward-facing TLS certificates, we want to get better time to market. We want to get better controls around this because, hey, I know this is an absolute surprise. We don't manage certificates properly. I know, shocking, right? But that's a problem. They're trying to deal with the challenges with issuance, getting certs out there. Who's issuing it? How are you allowed to issue it? Where can it go? And what they're looking at here is getting a faster adoption of these new practices, starting to focus on quantum-resistant algorithms. I'm going to talk a little bit more about this in a bit. Quantum's coming, and this is going to really put a wrinkle in things. Obviously, the broken business process, revoking certs, pulling them back, as well as being able to recover them, and dealing this challenges with getting just unmanageable errors you get with certificates. I'm going to talk a little bit about metadata in the practical section of this, and talk about the importance of this. Your metadata is really cool, and it's also one of the things that's going to help you streamline your processes, because if you don't do this right, you don't have your metadata right, it becomes a nightmare to do auto renewal and auto enrollment. So again, since we are cybersecurity and we are the keepers of everything, this is a challenge. This is actually a business challenge. I know that I joke when I say it's a cybersecurity problem. It's not. It's a business problem. You have to rotate these certs more often. Google's going to drive this. That means I'm going to have to test more often. So now doing this every year, every 397 days, it now becomes every 90 days. And every time I change that cert, I have to test. That means I've got to go through change windows, change approval processes, and that is going to be hitting the change approval board every probably 60 days. They're going to be asking questions around this. We have to schedule these changes, because you just don't throw a cert out there in a production system forward facing without causing a problem, because guess what? When that goes down, who's getting a call? We are, even though it's not ours. And then we need to start to identify where all these certs sit. Think about it. This one organization I'm working with has 1,000 certificates forward facing. 1,000. That's small. The number of certs they have internally is probably about 1 million. But anything that's publicly issued, here's a problem. This is the last one here. This does not become that easy. It's not like I just go out to GoDaddy or whoever and just issue a new cert. Depending upon how the purchasing processes are, I may be buying this through a third party. So if I'm trying to automate this, I just don't go out and renew the cert every 90 days. I actually have to go through, hit the reseller, get it. That takes time. So this is one of the things, again, another thing I'm dealing with right now as I'm trying to do automation for this client. They buy through a reseller. They're now negotiating directly with the certificate vendor in order to get this automated, because current state, this won't work. Quantum. Another one of those hot buzzwords, right? Quantum's going to throw a challenge into this. We're going to have to require quantum-ready algorithms to issue certificates. That adds a layer of complexity here, because these algorithms are more complex. The complexity in the algorithms now means that I'm going to take greater processing time when I'm actually running this web application. The days of 2048 RSA encryption or 4096 ECC encryption is going to go away. These algorithms are way more burdensome. That's going to have a direct impact on who's consuming these certs, how are they being managed, what's the impact on my applications, can they even support it? And I'm just talking about the certificate side. I get into the symmetric key side, this becomes even more of a challenge. This is coming. Now, it's not like this is going to happen next year. If you're going to ask my professional opinion on this space, you're probably going to see regulatory changes coming out in the next 5 years. That's going to require this. My humble opinion is you're probably going to see this in PCI and financial services first. So if you do payment card transactions and you've got credit card systems, you're probably going to need to start switching over to quantum-ready PCI systems in the next 5 years, or to have that requirement come down. Are they ready to break this stuff? Again, I can spend an hour talking about quantum itself, but the security risks aren't quite as prevalent as the regulatory requirements that are coming down. The NSA is already starting to require this. Now, it's kind of interesting that they're requiring it and the standards aren't approved. And I actually just sat in a conversation yesterday with NIST and a number of cybersecurity experts and cryptography experts. NIST is going to put these out in the next, they're talking July, which means they're going to put their stamp of approval on the algorithms. This then has to go through FIPS certification. The FIPS certification is probably going to take at least a year, if not 2, just to get that down. And then you have to get everything issued. So again, this is not a massive change that's going to happen right away, but if you're not planning for this now, it's coming. Get ready for it. So how do you get ready for it? Here's some questions to think about. Here's some questions to start asking yourself, asking your organization, asking your leaders, asking your business partners. How are you going to manage this? Again, we as cybersecurity professionals are the ones who are able to say, how are you managing it? I got to deal with my cloud ops, my DevOps, my IT folks, anybody who's standing up a virtual machine and saying, how are you doing this? Second part about this is, how are we going to get ready for this? This is big. This is going to require a lot of coordination with developers, with IT, change approval, compliance, to make sure that we can do this effectively, get this done right, and not break our systems. You start taking systems offline, it becomes problematic. The quantum one is, we just talked about, this is something to start planning for. Again, you've got about 5 years, and then that reality is going to hit, and it's probably going to be a regulation. We're really going to focus on these next two things here. How do we improve the processes? How do we go about this? And lastly, how do we streamline this? How do we start to automate this? You're going to hear me start talking about automation from two sides, auto enrollment and auto renewal. We'll dig into that a little bit, how that works, as well as how do you set the indicators up on it. So let's talk about our favorite part, policies and procedures. Yay, we all like writing policies and procedures, right? It's daunting. It can seem burdensome. This is a critical component to how you manage certificates. We have to start to put some structure in place in order to understand who can issue certs, what are the minimum requirements around it in terms of key lengths, expiration, how we manage certificate usage, how do we generate those keys. These are critical components of this documentation set called a certificate policy and a certificate practice statement that really drives and defines how an organization issues, uses, consumes, revokes, manages certificates. I do want to emphasize managed certificates because we are using certificates for a number of things. Some of it's cryptographic. I'm scrambling data using my asymmetric keys. My backups exist for 15, 20 years on some occasions. I need to be able to have that certificate in some location where I can pull it back in the event I have to go back and find something in that backup. So that management looks at things like revocation and escrowing. This is an industry standard approach. I mean, there's a number of regulations out there that talk about that encryption is required or addressable. HIPAA will say it's an addressable requirement. The only one up here that I can think of that has an actual cryptographic standard called out is PCI, which is why my opinion is that when quantum readiness comes out, that's going to be probably one of the first ones that gets picked up. NERC may come into that section. This is an interesting one. Who is familiar with the electronic identity and trust services requirements out of Europe and the UK? Cool, a couple people. Great. For those of you who are not familiar with this, and again, there's a big section on it in the back, I'm just going to summarize this really quickly. EIDAS states that if I'm doing electronic signatures, those keys have to be issued from a trusted certificate authority that resides in region. The keys stay in region. So I have to get my CA recognized and officially certified by a government entity before I can issue anything for doing document signing or any type of digital signing. Now, the interesting thing with the UK and the EU is that the UK recognizes the European Union's version of EIDAS, but the EU does not recognize the UK's version, even though they're identical. So it's an interesting thing. Again, in the appendix here, there's details on EIDAS. Again, look at the appendix of this document because there's a lot of really detailed language and examples in here and references. Let's start with the first part of this, roles and responsibilities. As I'm issuing certificates, I'm just going to set context. Not everybody can request a cert. You have to control that. So as we start talking about the roles and responsibilities here, I'm going to highlight 4 major roles here that are typically called out. Again, if you look at a CP or CPS that's publicly available, you look at the sample language I've got in this document, this is the first one. The requester has to be an authorized person or an entity inside my organization. My favorite part here, holds overall accountability and ownership for the certificate. That sets context. The company I'm working with, a couple of companies I'm working with right now, Cyber's handling certificate issuance. We have the CAs, we run it. We have the certificate lifecycle management. We're doing the reporting on it. We're helping to enable the auto enrollment. But we don't own the cert. Why? See right there. It's a funny conversation because I'm having a conversation with a colleague of mine, and this individual is a cryptographic expert and works for a very large retailer, and we just sat there for 20 minutes and debated the reasoning why somebody can go out and issue a cert, and when that cert expires, it's cybersecurity's fault. Again, we go back to the whole thing. I can go out and get a cert, I can issue a cert, I can put that thing out, use it, but then when it breaks, they come to us. Your CP and your CPS, or whatever security or certificate policy document or procedure document you put in place, assigns that. They own it. And it's really important because they know what it is, they know where it sits, they know how it's used. We don't. There's a lot of things in cyber we don't know about. We provide the tools and controls around it. This is a really key one to set in place. Second one's this thing, your registration authority. This is the person on cybersecurity who validates it. So this request comes in, we look at the request and say, yep, they're good. We can approve it. Now, this seems really manual. This actually happens in an automated fashion once you get things rolling. But this is a very key role within the CP and CPS process that sets the review of who's issuing the cert, who's requesting it, why is it being requested, does it line up with our standards around metadata, et cetera, is it following our encryption key standards, et cetera, perfect. Of course, the CA administrator, certificate authority administrator, is the person who manages the certificate infrastructure. Working with your HSMs, putting all your templates in place, making sure you're issuing authorities, revocation lists. That whole structure is handled by the CA administrator. Very important to define who these folks are because when your infrastructure breaks, these are the people who are going to fix it. And lastly, your CA auditor. This should be an independent group inside of your organization. This could be compliance, this could be audit, whoever. You want to have an independent body who comes in and takes a look at what's going on, just make sure you're doing it right. Really important because, as we talked about earlier, there's a lot of regulations out there that say you have to have something in place. Better to have a third party or a outside cyber organization looking at what you're doing. I come from the audit industry. I used to work for Big Four. Yeah, you don't audit your own work. You have somebody else do it for you just to make sure it's all in check. This is probably one of my favorite parts of this conversation, naming conventions. It's really important to get into having a standardized format of what that metadata looks like, how you're naming your certs, how you're defining who is the primary owner of this, who's your secondary owner. Those metadata fields are instrumental in helping you understand, manage, track down who owns this thing, when's it going to expire, and put a lot of context behind what that certificate is. Is it a critical infrastructure certificate? Who owns it? How's it used? Where's it sit? And those are really key things. If I can look at that in a console and go, yep, I know who it is, I know where it sits, I know where it's issued from, I can track it down a lot more quickly. Because when things go pear-shaped, and they do, if you don't have that information at your fingertips, it really becomes problematic. There was a situation here, I want to say 2021 or 2022 with a payment processor who was updating a root certificate. Nothing wrong with that, standard process. They pushed that thing out, great. So I've got my root, I've got my intermediate certificate going out, awesome. Now, like every good organization, they had good separation. I had separation of my internal and external systems. Problem they had was that the internal systems where this root certificate was deployed was not communicating back with the issuance and revocation authorities. That root expired inside of their network. And they started to see a cascading failure of processing payments. Now that meter's running at a 7-figure cost per hour. It took them a couple hours to find it. You can actually go out online and look this up. But they had to track down why that happened. And again, this was not a, I forgot the cert was there. They'd had actually a broken infrastructure process here that caused this to go down. By being able to identify which system went down, where it was issued from, they're able to start to track down like, okay, we have a problem because this can't call out to the CA. and they were able to fix it. But without that metadata in place, if it was problematic, you would never know where that cert came from. So specifying those fields and minimize the issues with renewing and auto-enrolling certificates. So what's this look like? This is a metadata field example. It's got probably 8 fields up here that, typically in a certificate I've seen anywhere from 10 to 15 fields. Again, it depends upon how much detail you want. This is an example I've actually working with a couple clients on structuring this out. The serial number is automatically generated. Here's my primary contact. Now notice that this is not an individual user, right? This is actually a group, which is really helpful because, again, people leave. People leave the organization. This field here is an internal one. This lets me know who's managing it. And by when I'm talking about managing, it's like, is this an IT internal system? We control switches. We control web servers in the back end. We have Active Directory. We handle the application servers, et cetera, for like databases. Yeah, that's going to be an IT managed one. Otherwise, it's like it's not. Again, with this organization, this is a global organization. We're working across 15 different teams with Imperva WAFs, F5 firewalls, Java key stores, Tomcat servers, IIS, Active Directory, 4 domains of Active Directory. Yeah, I was dealing with 15 different people, but we were all in sync. And this was actually a good way to see this organization work because cybersecurity said, yeah, we have the CLM, we help you issue certs, but this information right here is really letting me know who's managing it. What's the environment? Is it production, non-production? What division owns it? What department? Is it critical? Big one. Because I'm able to start doing reporting on is it a critical cert? I know up front which ones are going to go out, which ones I got to keep my eyes on more quickly. Is it internal, external? Pretty self-explanatory. This is another one. This is a big field we have to think about. Auto renewal, and I'm going to talk about this. We do want to automate as much as we can. There are times where we have to turn off the auto renewal because if the CLM will sometimes just take it, renew the cert, it gets a notification the cert's been renewed by the certificate authority, takes it, pushes it right out. If our change approval processes state that we can't do that, we have to change that field around. So, use cases. Not all certs are created equal. You heard me say this thing, same thing about data. Data is not created equal, certificates aren't created equal. A couple things to think about is just structuring the way that you're going to issue and define certificates. Break it down in these categories. What's the level of importance? What types of systems are they used for? What type of role? So it could be a user identity, it could be TLS, machine identity. It's an internal or external user. What's the duration? Starting to define certificates are going to have different durations. I'm working with a commercial appliance company right now, helping them build out an IoT certificate program for issuing and selling new products. And these things are going to be able to phone home. That cert on that machine, which is the baseline identity, it says this is an authorized freezer sold from us, or refrigerator, or washing machine, has a 20-year lifespan. You'll probably ask me why. Well, if you're like me, who has a smart appliance in my house, guess what I don't do? I don't plug the thing in. I don't need it. I don't need my refrigerator telling me it's time to go get more eggs. I know when it's time to go get more eggs. The purpose here is that there are several certificates on that, but that is the baseline one that in the event somebody leaves this thing offline for 5 years and then plugs it in, that thing can at least crawl back in and say, I'm authorized to do something. At that point, then all of the other certs start to update. My identity cert, my code signing certs that are used to update my firmware, et cetera. So it's really important to understand what those keys are. And then, do I want to reissue keys? Why would I want to do that? Well, let's break this down a little bit. Again, I started talking about these assurance levels here. I'm going to start at the bottom. Do I retain the existing key pair or do I issue a new one? And there's some reasons why you probably want to issue a new one. We talked about the expiration. We started talking about some of the use cases. Here are some examples. So as we break this down from a full end-to-end use case, I can say I've got an Active Directory computer here. It's pretty reliable. I know what type of system this is. I don't need to have a lot of assurance on it because it's outside my network. I manage the thing. It'll renew that certificate every 2 years, and I'm going to retain the key pair. So literally, I just update certificate revocation, reissue new key pair. Great. This is one where I've got an external user. Got a little bit higher assurance around that. I'm going to have it expire every year, and then every time I issue a new cert for that person, it's a new key. Now, why would I want to do that? Well, let's just say, for example, they just happened to get creative and get a quantum computer and break the key pair. Yeah. Well, first of all, good luck. But second of all, it's just good security practice. If you're on the outside of my organization, I have less reliance and trust on you. So, generating, protecting keys. Pretty standard stuff here. As we look at doing this, one of the things I would recommend is start using cryptographic service modules. Store your keys in a good secure location, have people stay on top of this. Really important. This is a big one. 2 reasons. One, in the event somebody leaves, I've got a backup, and I can get into this thing. When I'm accessing my master keys, I want to have at least 2 people present. You'll hear the term M of N, 2, 3 people. There was a situation, I want to say 2 years ago, where a software company that stores passwords had a social engineering attack. They attacked one of the developers. That developer was one of 4 people who had access to the master key, and they got the master key. Game over. All your passwords are unlocked, all your data's unlocked, done. Had they had an M of N control in place, they would have stopped this. Escrowing your keys I talked about earlier, again, there's going to be situations where we have to recover the keys. And then lastly, the backup. We want to have a good, reliable backup. In the event something goes wrong, HSMs do break, they do fail. But you have to have a backup of those so that you can get your system back up and running pretty quickly. Again, this is all part of the CP and CPS. We spend a lot of time talking about the process. Let's get into the weeds. Let's talk about the tooling. How does this work? So we look at certificate lifecycle management. There's going to be 5 main areas I talk about. I'm going to start with how do you enroll certs. Again, coming from my data side, I always start with what I know. Where are the certificate authorities, certificate stores I can go after right away and enroll? Second one's discovering. Then we're going to start talking about how do you connect these things, automate them, and provide reporting, because reporting is going to be the key part of this. So, top level. How does this work? I've got my certificate lifecycle management solution here in the center. You can be either doing stuff on-prem. This could be middleware. This could be an API call. I have stuff on the front end. Again, this could be a cloud gateway server. This could be another API call, depending upon the infrastructure, depending upon the solution. I want to use these to go out and actually connect to my known repositories. I've got stuff in the cloud. I've got CAs in the cloud, whether they're public or whether they're part of infrastructure as a service. Same thing on-prem. I have web application firewalls, IIS servers, certificate authorities from Active Directory, Java key stores, enterprise Java Bean certificate authorities, name it. I connect, I find out where those are, I authenticate. Once I authenticate, I can start pulling this information back. I can pull the certs back and put them under management. I'm starting to get the metadata. I'm starting to do a review of that metadata because I want to start understanding what's not right, what needs to be fixed. And once this certificate's in here, you can change the metadata on a cert without reissuing it. So you can actually communicate back to your certificate authority, your issuing authority, and get that metadata updated so you can get it into your standardized format. Really critical component about managing certificates is getting that stuff into the right location. Second part of this is discovery. There are ways of doing discovery using TLS. There's ways of using the APIs. And you can need open protocols. Again, same process here. I'm going out, I'm finding out where these repositories are, I'm pointing my CLM tool at it. The tool goes out and actually looks for it. They'll look for certificates that are sitting out there. Again, I'm doing a TLS pool, an SSH pool, SFTP pool, whatever. They can go out and find these things and start to pull the information back on that. Once I'm able to do that, again, same process here. I'm now using that tool to pull the certificate back in, get the management around it, you look at the metadata, and start generating reports on it. This is how I start to get visibility around what types of certs are actually issued out there. Where do they sit? One of the things I do want to bring up, and I didn't cover this in the naming convention, is wildcard certs. You use that section in the main naming convention to minimize the number of uses around wildcards. Wildcards are the bane of our existence because they can get slapped on anything out there. We want to control that. We want to have certificates that are very specific to our organization, and their use cases are very well defined. Now comes the fun. There's a lot of interconnectivity you can use within certificate lifecycle management. Again, we're starting down here in this part with our clouds, with our gateways or APIs, et cetera. New component up here, Acme and SCEP. Acme is the automatic certificate management enrollment, which is used for managing applications. And then you've got SCEP, Simple Certificate Enrollment Protocol. These are really important when I'm starting to deal with application onboarding, when I'm dealing with the issuance and management around mobile device management. I'm using SCEP to connect up with things like Jamf, Intune, AirWatch, mobile device management. Once I'm tied in with that using SCEP, or once I'm using Acme here and doing JSON calls out to actual applications, this could be platform as a service, this could be a code developer who actually has this JSON call built into their application front end, we can start using these solutions here to connect out to a whole host of things. Again, we also have the same connectivity here. This is a public CA. I'm dealing with this with DigiCert, GoDaddy, Entrust. I'm tying this into my cloud architecture, Google, Azure, AWS. I'm taking all of those certificate authorities that are in those cloud environments and I'm tying them into my certificate lifecycle management solution. Same thing, I'm pulling in this information, I'm getting information on the certificates themselves, I'm pulling the metadata in, I'm starting to identify and manage that metadata. So we've done a couple things here. I've taken stuff I've known, I've put it under inventory. I've gone out and I've found my certificates. I'm putting that under inventory and control. I'm now doing all the connectivity. Third part of this. Fourth part. Now we start enabling the auto enrollment. Again, same infrastructure here. A lot of this is repetitive, but it's the same steps, which is kind of the nice thing. First part about this is a little bit different, is that there are templates out here. Once I'm starting to work with my CAs, I want to pull those templates in. Those certificate templates are going to be key to how we do issuance and controlling who does what. Again, we're defining this in our CP and CPS. Those templates get pulled in, they're aligned with our requirements, our policies, our standards. We're doing the authentication into here. By the way, this authentication process, use SSO. Make it really easy upon yourself. You can use this with privileged access management. You can do this with things like Ping and Okta, which is what I'm doing with this organization, because it goes back to that principle of we, as cybersecurity professionals, provide this, and we help stand up the CAs. My application owners who own my F5 firewalls, my IIS service, et cetera, and get all these certs, I want to give them the ability, using their credentials, to go into this CLM and actually manage their certs, which is really powerful. Now I'm giving them the ability to go out and issue certs. They are authorized requesters. They know what their certs are used for. They can actually go into this console and start to handle the device requests, start handling requests for new certs, making sure their certificates line up with the metadata requirements we have. We also will be able to generate reports on this and enable this. This is a big part of this. Active Directory services, for example, will do auto enrollment. The moment I plug a laptop in, the moment I stand up a server, create a new user identity, bang, cert gets automatically pushed out. Easy peasy. I start dealing with things like web application firewalls, web servers, et cetera. Those certs expire. This is the auto renewal process. That means when this certificate gets within a certain window, I'm pushing a new cert out. We talked about Google. That's going to happen every 90 days. Ideally, you're doing it every 75. Why? Why would I not want to wait till day 90 to go out and try to do a cert renewal? It's going, what's that? No knife edge cutovers, exactly, because, you know, we all know things just happen, they work perfectly all the time, right? Wrong. 15 days is typically what we see, which is kind of like here. It's one of the things I recommend. When you're doing notifications, set them up, 45, 15, 45, 30, 15. I hit day 15, your renewal is going to happen. Or your certificate's going to expire, and I'm going to tell you it's going to expire and your system's going to go out. The dashboarding is really important here because that's going to give people visibility. Again, I want to give the certificate owners the ability to take a look at what's going on here. This is big. Enabling this in auto enrollment and auto deployment is critical, whether I'm looking at SCEP, Jamf, all those systems, whether I'm looking at web application firewalls, IIS, et cetera. I want to enable as much automation as I can. That makes it easy for people. This is key because we all do things through ticketing systems for the most part. So how do you integrate this? I'm doing this right now with ServiceNow and Remedy, working with major certificate lifecycle management manufacturers. And this is a key part of it. My user logs in, they request a cert through ServiceNow. That generates a request within my certificate lifecycle management solution, which pushes out to the CA. CA pushes out a new cert. CLM notifies the user, notifies the requester, everything's good to go. Auto renewal side. The CLM will actually notify ServiceNow that I'm about to do an auto renewal. It'll send us out, create a ticket. The CLM will then go out and grab the cert from here, push it out to the system, update the ticket, notify the user. End user does nothing. They get notified. This happens like that. This is a big thing I'm doing right now for 2 clients, and it's awesome. It takes their workload, cuts it in half, if not 2/3. And this is what it looks like end to end, folks. This is everything we just talked about. Everything from discovery, to auto enrollment, to auto management, integration with SCEP, whole picture. This is how CLM works. This is contingent and works within your policies and procedures, but this enables a whole lot, makes it a lot easier within your organization. So, closing remarks. There's a number of things that are happening right now that's going to drive change and how we have to manage certificates. Regulatory side, industry side, this is coming fast. Document this stuff. Put the roles, responsibilities, issuing requirements, certificate types, expiration, all that into documentation, define the policies and procedures. You have that in writing. That gives people the template and the guidelines on what to do. And then leverage the tools to automate this. Don't start here. You can go out and spend a lot of money on a CLM tool and get nowhere. I'm working with a company right now that's had one of these for 5 years, and guess what they've done? One use case. And this is a large organization, and I've literally sat down with their management and said, what are you doing? Because you've just wasted 4 years and you've got a 5-year renewal coming up. Bad management. Don't start here, start here. What do you do? Where does it go next? Just take a look at what you got going on inside. What are my policies and procedures? What are my documentation? What are my use cases? Second part about this is actually start identifying who's doing this. Start small. Break this down. Identify your most critical systems and start there. And as you get into this, around this time, if you've got CLM, start looking at it. Start looking about how you can start to do the discovery and management. And as you get out in the next 6 months, figure out where you can automate. Figure out how you can expand your management around this. This is how you're going to get ahead of a curve. This is how you're going to start to get better oversight and management around your certificates. So, went a little longer than I expected, but I wanted to share some examples. So, what questions do you have? Comments, thoughts?
First of all, appreciate the presentation, especially the piece on the deployment. Work in the payment industry and have a pretty significant footprint globally.
Yep.
One of the items, though, that we are, 2 items. One is that we are not seeing as, when we talk about 90 days, that basically dictates automation. I mean, we struggle already to get all the certificates taken care of in 13 months. 90 days just means it's just impractical. But we're not seeing as much on the vendor side providing us the interfaces to really be able to support this, whether it's mainframe, you talked about some of the other network vendors and such. Where do you see that space in terms of vendors supporting the ability outside of the browsers who are able to do it pretty easily? But where do you see that lack of capability when we expect pretty rapid adoption of this 90 days?
Yep. So I think in terms of the vendor space, if we break that down into 2 aspects, if we look at like your certificate authorities, again, Entrust, GoDaddy, whoever, your forward-facing authorities, I'm going to see them in a position to be able to actually generate and renew those certificates very quickly. Where I think it's going to get challenging and where you get that separation is where if I'm dealing with like a network vendor, so I'm dealing with, I don't know, a SonicWall, Palo Alto, Cisco, firewalls, or web application firewalls, that adoption is going to really come down to how well they can automate. And also, it really comes down to change control process. Because what I'm seeing, like in the case where I'm working with this vendor on their F5s, they're a bit apprehensive to go and do that auto renewal in some sorts. That's where you have to break it down. Because what we need to do is get change approval processes on board with. This isn't as big of a risk. I think that's one of the things we always talk about, is that when we do a cert renewal, is it going to cause an outage when it goes down? And I think these forward-facing systems will fall into that category, and what we're advising people on doing is you put them in a category where you can just do the auto push and just trust it. Because I think often where we see things fail is the change approval just gets in the way. Mm-hmm. And they make it really cumbersome to get done. It's like, look, if this thing goes down, I've got 3 failover systems that'll work. So you stagger it.
All right. And last thing and comment, I work heavily in the quantum computing space, and in the payment industry, that ecosystem moves extremely slow. I've been in it long enough to have done the SHA-1, SHA-2. We still have point of sale terminals still running SHA-1 certificates. Mm-hmm. And so when we're talking about crypto agility and that industry moving at the speed that it does, 5 years to, where you're saying 5 years to start, because concern in terms of how long it takes. I mean, we're still having AAA 2 still a major part of the infrastructure. It almost seems that time frame is to start now.
Yep, I would agree. And I think to your point, that the infrastructure is going to take on, the payment card industry is going to take a little longer to get up and dated. Start on it now and figure out, again, what has to be changed, what could be cordoned off, et cetera. That's what I'm recommending with clients.
Hey, Jeffrey Bunch with AMC Theaters. We're doing a lot of what you're saying with spreadsheets and Entrust right now.
Yep.
We're doing cloud transformation, worried about Google. So as Optiv, Avar, what products are you seeing your customers have success and satisfaction with off the shelf for a CLM?
So, from our particular, tell you the big vendors in this space right now, Venafi from a CLM perspective, Keyfactor is another one. DigiCert and Entrust are going to PKI as a service. So there's a lot of options out there in terms of having certificate lifecycle management in the cloud, because I think that's what organizations really need. Is you need that system that can give you that centralized visibility and inventory and management of it.
Do they integrate with Active Directory, with
Yep.
like Entrust, to integrate with your AD controllers?
Yep,
Okay.
all of them will.
Okay, cool. Thank you.
I've looked into the Acme protocol a bit, and it seems like a fantastic thing for sort of mom and pop web shops, but I'm struggling to get my arms around how to do like an enterprise Acme implementation that would be centralized.
Yeah, Acme itself, in terms of, I think there's 2 ways to break that down. In terms of the way the actual protocol works within the certificate lifecycle management, it's a pretty straightforward call, right? Using JSON files, et cetera. I think where we see organizations like as you're pointing out, one of your size, is how does that tie into your DevOps operation? How does that integrate? How reliable is it? Because Acme by itself, those CLMs will just push it out all day. If your DevOps operations can't support it, they'll struggle. So it's less about the protocol and more about the processes. I think I'm out of time, but I'm going to be available. I was happy to step out in the hallway and chat with you some more, answer more questions.